When we name special things like acids, we have to give them special names too because they're so commonly used. We have some special rules there, so let's go through these rules. We'll start with this one. You can see we have binary acids. Binary, again, means two. It means the acid is only comprised of two elements. So let me move up front. When we deal with a binary compound like HCl, and this is a very common acid that we use in the lab all the time, if we named it as is, we named the metal hydrogen, and we named the non-metal chloride. Remember, IDE at the end, so hydrogen chloride. However, to make it an acid, we just put this in water. It's aqueous. When we put it in water, it becomes an acid, which is very different than this regular compound. And because of that, we need to give it a special name. Here's the formula. When it's a binary acid, we use hydro. They just drop off the hydrogen part, the gen part. Hydro, you take the root of the nonmetal. In this case, it's chlorine, so you take the root as chlor, and end with ic. So it's hydrochloric acid. Hydrochloric acid. If we look at HBr, again, if we name it as is, metal first, nonmetal second, hydrogen, bromine becomes bromide. Hydrogen bromide. If we put that in water, and we would write it with an AQ under it, we put a little AQ here and here, means it's an acid now. Once it becomes an acid, we use this formula, hydrobromic acid. Hydrobromic acid. Here we have hydrogen fluoride. Okay. Put it in water, we put a little AQ here. It'd be aqueous now. It's an acid. So again, now, hydrofluoric acid. And so forth. A whole nother set of acids, and most of them contain oxygen, that have their own naming system. And let's take a look at one. This one here is hydrogen and acetate. You look up this polyatomic ion on the polyatomic ion chart. You don't have to memorize it, it's right there. You just look it up. The metal's hydrogen, the non-metal is acetate. So again, name it as is, hydrogen acetate. When it becomes in water, we put an AQ here, it now changes the name. We drop the hydrogen altogether, and ATE will become IC. So it becomes, drop that, acetic acid. Acetic acid, which is vinegar, by the way. Let's do another one. Hydrogen carbonate, right? You look this up on the polyatomic ion chart. So the metal and the non-metal. Hydrogen carbonate. If we put it in water, it becomes AQ here. So now it's an acid. We drop the hydrogen in the name. The ATE here becomes IC. So it is carbonic acid. So you need to practice these. We have hydrogen nitrate. So this would be, drop the hydrogen, nitric acid if you put it in water and have an AQ. Hydrogen sulfate. Put it in water, AQ, it becomes sulfuric acid. So again, the ATE becomes IC. Some of the compounds are called sulfite. We'll look at that in just a second. And the ITE is going to become OUS. These polyatomic ions a lot of times are in series. And again, they're based on oxygen. So we had talked about sulfate. It's SO4 with a -2. And I like to keep it in parentheses so you keep it together. This is sulfate. Again, you look on the polyatomic ion chart. But this can be also SO3. See, it has one less oxygen. That means when we name it, we need to give it a different name. This would be sulfite. And actually, there's another one, SO2. This would be hyposulfite. Hypo means under, like hypodermic needle. And then you can get one more, SO5. This is sulfate. This has one more oxygen, so the word that means more or above is hyper. And they just use the word per. So watch this. It goes persulfate, sulfate, sulfite, hyposulfite. That's how you would name that series. Let's make them acids. If we make all of these compounds, we'd have hydrogen sulfate. Add an oxygen, hydrogen persulfate. Take away an oxygen, hydrogen sulfite. Take away another oxygen, hydrogen hyposulfite. If we make them acids, we'd say AQ for each one of these. Now the name changes because they're acids. So here, because it's not binary, we're going to drop the hydrogen in the name. And if it ends in ATE normally, we're going to change that to IC. So hydrogen drops, it's sulfate, right, becomes sulfuric, except it has one more oxygen, so we need to say per sulfuric acid. So this one is per sulfuric acid. Here, drop the hydrogen, sulfate, ATE, becomes sulfuric acid, so this is sulfuric acid. Hydrogen sulfite, the hydrogen drops, the ITE becomes OUS, sulfurous acid. And here, hyposulfurous acid. Let's try one more example for practice. Here we have the phosphate series. This is hydrogen phosphate before we put in an acid, but you can see here's an AQ, so that means it's an acid. To name it, we would say phosphoric acid. Phosphate, ATE becomes IC. One more oxygen, perphosphoric acid. Perphosphate becomes perphosphoric acid. Again, it's acid, so here, this is hydrogen phosphite. Put it in water, and it becomes phosphorus acid. The ITE becomes OUS. Hydrogen hypophosphite becomes hypophosphorus acid. Kind of a mouthful. So you can practice on all those different ones in the polyatomic ion chart to help you with these.